Comet 3I/Atlas lovers don't need to lose hope or fall into despair, because according to experts who have analyzed its latest observations in detail, our favorite interstellar visitor most likely did not explode or break apart the way some early reports suggested. The concern began spreading when on November 10th, Futurism reported that Comet 3I/Atlas might have fragmented after emerging from behind the far side of the Sun. The science and technology outlet reference calculations posted on the blog of Harvard astrophysicist Avi Loeb. Loeb based his claims on a newly captured image of the comet, taken by two small telescopes in Spain on November 9th, and he argued that the comet appeared to have lost a significant amount of mass. According to him, this loss hinted at the comet having undergone some catastrophic breakup event. Because 3I/Atlas is only the third known interstellar object ever observed passing through our solar system, the possibility of such an event naturally drew widespread attention, curiosity, and worry among astronomers and space enthusiasts. But as quickly as the speculation spread, it began to face scrutiny from scientists who have been more directly involved in observing the comet. This is not the first time Loeb's interpretations have stirred debate. He has gained attention in the scientific community for proposing bold, unconventional ideas, including his repeated suggestion that certain cosmic objects, this comet included, could potentially be alien spacecraft or artifacts of extraterrestrial engineering. While such ideas generate media buzz, the majority of researchers emphasize that extraordinary claims require extraordinary evidence, and no such evidence currently exists. In fact, the consensus among astronomers is that Comet 3I/Atlas is behaving like a completely natural interstellar comet, showing no signs that it has exploded, fragmented, or transformed into anything unusual. Qiqing Zhang, a postdoctoral researcher at Lowell Observatory in Arizona and one of the scientists closely monitoring 3I/Atlas, expressed confidence after reviewing recent imagery of the comet. In his email to Live Science, Zhang stated that all the images he has analyzed show a normal, healthy-looking comet with no indication of the nucleus breaking apart. The nucleus, the solid central body of a comet, is crucial for determining whether the comet remains intact. If it had fragmented, astronomers would expect to see multiple bright knots of material instead of a single concentrated core. Zhang noted that nothing of the sort appears in the images, strongly suggesting that the comet remains structurally sound. His statement directly contradicts the alarming interpretation that the comet has undergone a violent breakup. Instead, it supports the idea that the comet's appearance may have changed simply due to normal cometary activity, variations in illumination or observational angles, as it moved relative to the Sun and Earth. Comet 3I/Atlas has recently completed a dramatic phase of its journey. It passed behind the Sun from our viewpoint on Earth, disappearing briefly from telescopic observation. During this period, the comet reached perihelion, the moment when it comes closest to the Sun, on October 29th. Perihelion is an extremely important stage for scientists studying comets because the intense heat and solar radiation provoke physical and chemical changes that reveal key information about a comet's composition. As comets approach a star, the increase in temperature causes the ice on their surfaces to sublimate directly into gas. This process not only releases vapor, but also loosens dust, minerals, and organic compounds that have been stored inside the comet since before our solar system even formed. Because 3I/Atlas originated from outside the solar system, studying these materials could provide valuable clues about the chemistry and conditions of distant star systems, information that scientists rarely have a chance to examine firsthand. As the comet emerges from behind the Sun once again, astronomers on Earth are watching it closely. With each passing night, the comet reveals more of its structure and activity. The freshly sublimated gases can burst through cracks or weak spots on the comet's surface, sometimes erupting as enormous jets that extend thousands of miles into space. These jets can look dramatic in photographs, but they are entirely normal for comets undergoing solar heating. The gas and dust released form the coma, a glowing, cloud-like envelope that surrounds a nucleus and gives comets their iconic fuzzy appearance. Meanwhile, the pressure of solar wind pushes dust particles away from the comet, shaping them into long tails that stretch across the sky. These tails can span millions of kilometers and are illuminated by reflected sunlight and energized particles, making them visible even through modest amateur telescopes under clear conditions. The sun's ionizing radiation plays a major role in making these cometary features bright and easy to observe. When solar particles strike the gas surrounding the comet, they strip electrons away, creating ions that glow vividly. This glow allows even small backyard telescopes to capture beautiful details of a comet structure. For interstellar comets like 3I/Atlas, this is especially exciting. Every new observation provides researchers with data about how comets formed in other planetary systems might behave when exposed to our Sun, and whether they share characteristics with the comets that were born here. Since only two previous interstellar objects, Oumuamua and Comet 2I/Borisov, have ever been observed, every detail collected from 3I/Atlas is scientifically precious. Many researchers are thrilled that the comet is now rising higher above the eastern horizon as seen from Earth. This improved visibility gives both professional and amateur astronomers a chance to track it over the coming weeks. In much of the northern hemisphere, observers with a small 6-inch telescope can catch sight of the comet in the early morning or late night sky, depending on local conditions. For many, seeing an interstellar visitor is a once-in-a-lifetime opportunity. The fact that the comet appears intact and active makes it even more worthwhile to continue monitoring. These observations will help scientists map its orbit more accurately, estimate its mass and density, and understand how interstellar comets interact with the solar environment. As excitement grows among skywatchers, many astronomers caution that interpreting comet behavior can be complex. Comets can brighten or dim unpredictably based on how sunlight strikes their surfaces, how much gas they release, or how dust clouds temporarily obscure their nuclei. Sometimes a comet appears faint not because it has broken apart, but because observers have viewed it from an angle that hides its brightest features. Even changes in image processing techniques can make a comet seem different from one day to the next. Scientists analyzing 3I/Atlas emphasize that conclusions should be based on multiple consistent observations over time rather than on a single image or calculation. This is why many experts remain skeptical of Loeb's interpretation. While Loeb is respected for his contributions to astrophysics, his tendency to publicly speculate about extraterrestrial technology attracts criticism from researchers who prioritize conservative, evidence-driven explanations. With 3I/Atlas, most astronomers believe the simplest explanation remains the correct one. The comet is behaving like a normal interstellar body responding to solar heat. No sudden explosion, no alien spacecraft, no catastrophic fragmentation, just dust, gas, and ice reacting naturally as they have for billions of years. In the coming weeks, as 3I/Atlas continues its journey and climbs higher in the sky, astronomers expect to gather even better data. The comet will reveal more details about its structure, rotational behavior, and chemical makeup. Spectroscopic observations, where scientists split the comet's light into wavelengths, will help identify the specific gases escaping from its core. These measurements can teach us whether the materials in 3I/Atlas resemble those found in local comets, or if they reflect a different chemical history shaped by another star system entirely. Each discovery adds to our understanding of how planetary systems form, evolve, and sometimes send icy messengers drifting through interstellar space. For now, space enthusiasts can breathe a little easier. Despite dramatic headlines and premature speculation, Comet 3I/Atlas remains an extraordinary and intact traveler from another star. Its continued visibility offers scientists and observers the rare chance to witness a cosmic visitor that has journeyed across unimaginable distances, carrying secrets from a distant corner of the galaxy. And as long as it remains bright and stable, the world will keep watching, learning, and marveling at this interstellar wanderer as it passes through our solar neighborhood, reminding us of the vast, mysterious universe beyond our own sun.